Hi everyone, let's continue working on functions represented by formulas, and in particular a quadratic function represented by a formula. And let's try to really embrace the algebra skills practice that this gives us. It's really important stuff. Okay, so we are given a function, and the biggest rule when you're working on these function notation problems is to really commit to that definition you're given. So whenever I see the function h referred to, I am going to know that I have to follow the rule that says you're going to take your input, square it, multiply it by 2, and subtract 3. So that's my order of operations here. First square, then multiply by 2, then subtract 3. So 1, 2, 3. All right, the first input I'm given is -2, so I'm going to refer back to my function h rule and say I need to take that -2 and square it and multiply by 2 and subtract 3. And the parentheses are important here. If in doubt, throw some parentheses around your input so that you don't make any mistakes. We don't need to square 2 and then make it negative. We need to square -2, which will give us positive 4. So we're going to get 2 times 4 minus 3, which is 8 minus 3, or 5. So that's our first one. We're going to next start including variables in what we're plugging in. So we have h of 5t, which means we're going to refer back to that function rule h, and we are going to say our input 5t should be squared and then multiplied by 2, and then we subtract 3. So that will give us 2 times, exponents first, so 5t squared. Again, the parentheses are really important. When we square 5t, that means 5t multiplied by 5t, and we get 25t squared, and then minus 3. So when we're all done, we have 50t squared minus 3. All right, really important compare and contrast here. That was h of 5t. We were inputting 5t. Next is 5h of t. So that is saying take the output h of t and multiply it by 5. So we'll take 5 times h of t, which is the same as 2t squared minus 3, again just referring up to our function rule, and that one we just get to take straight from what's written there. We are plugging t in just like the original function was set up, and technically that's not bad there. I think I'll distribute. I don't see any reason why I want the parentheses here, but distributing versus not distributing, not always obvious which one is simpler. So I see a 10t squared minus 15, and I would leave my answer like that. Notice I am being asked to plug something in or do something to my output and give the result. There is nothing about solve here. You might notice that down at the bottom of the page it says solve. I want you to think really carefully about that. A really common mistake early on when we're working on all this messy algebraic function stuff is to look at every problem and want to solve for t. There's nothing in the directions of A, B, C, D, or my second D here, which I guess should be E, that say solve. It's not until we get to the last two parts that we should actually be solving for t values. This is just set something up and simplify if possible. Okay, next on my list, I am supposed to find h of t plus 5. So I'm inputting a t plus 5 into my function, and this function h takes your input, squares it, multiplies by 2, and subtracts 3. So that I would simplify a little bit. Remember, t plus 5 squared is the same as t plus 5 times t plus 5. I think I'll multiply the t plus 5 times t plus 5 first, but you could also distribute the 2 in first. If you're going to do it, you only distribute in through one set of parentheses. If you distribute a 2 into each set of parentheses, you've actually multiplied by 4. So just be careful, depending on what order you do this in. If I multiply out the t plus 5 times t plus 5, I get a t squared. And then from my outside, I'll get a 5t, and from my inside, I'll get another 5t, so that's a total of 10t. and then 5 times 5 will give me 25. So just foiling that out. Now I'll distribute the 2 in. So I end up with 2t squared plus 20t plus 50. And then my final step for this one will be 50 minus 3 is 47. And just like that looks great, if you can get it in factored form, that would be fine as well, but there's no reason in this one that I have to factor. If I was solving for a t value, I would think factoring would be a good choice. But here, since I'm just simplifying, I think factored versus not factored are equally simplified in this one. And again, avoid the temptation to make that equal to 0 or something else. That's just equal to h of t plus 5, and I'm all done. Okay, next the big one, which is the difference quotients. If I am simplifying the difference quotient, h of t plus 5 minus h of t all over 5, the first thing I want to do is fill in all those pieces carefully. So I already found h of t plus 5, and I even simplified it. If you haven't already done that, you can do it as side work, or you could just plug in this unsimplified 2 times t plus 5 squared minus 3 and work on the simplification within this fraction. Either are fine, but if you've already set up part of it, go ahead and use that. So I'll have a 2t squared plus 20t plus 47, and then I need to subtract off the original h of t. The original h of t is listed right at the top of the page. It's a 2t squared minus 3. And then I'm supposed to divide all that by 5. I'm going to throw parentheses around that first one as well, although I don't need them in this case because there's no multiplication or exponents or functions applied to that first chunk. But just so you can really see, the h of t plus 5 is the first set of parentheses and the h of t is the second set of parentheses. So we need to get that fraction set up, and we want to be very careful with that second set of parentheses that we distribute the negative sign through. That's the number one difference quotient error, is not distributing through a negative sign. So when I do that, I have 2t squared plus 20t plus 47 minus 2t squared, and then that becomes a plus 3. Very careful with that distribute. All right, I can do, I don't know why that became a 4. Let's make it a 3 again. There we go. I can combine here, and one nice thing I see is that the 2t squareds are going to drop out. I have 2t squared minus 2t squared, that adds up to 0, all gone. The other thing is I have a 47 plus 3, which equals 50. So I have a 20t plus 50. And that's actually looking pretty good, but I can do better. It's a fraction. You should always try and reduce fractions. In this case, if I could factor out a 5, I would be able to reduce. So if I factor out a 5, I get 4t plus 10, which means when I cancel, 5 divided by 5 is 1, all I'm left with is a 4t plus 10. And typically you will get quite a bit of simplification for these difference quotients. That's kind of a byproduct of how they're set up. So do expect to be able to reduce fractions. Do expect to see nice things like the 2t squared minus 2t squared pop up. If nice things aren't happening, you might want to look back and make sure, 1, that you set up correctly, and 2, that you distributed negative signs. Okay, last part of this one. We have a little bit of solve to do, and this is where I want you to not go on autopilot, really read directions. These say solve, and that's why we're solving. Up above did not say solve, so we were not solving. We were setting up and simplifying. All right, so h of t equals -1. That means we should take our original function, h of t, which was 2t squared minus 3, and set it equal to -1. We're working on solving quadratics, so you can set them equal to 0 and try and factor. Sometimes you can use square roots. This is actually a great example. I could use a square root here, and the reason that I can tell that I can do that is I don't have the t squared term and the t term floating around. I only have a t squared term. So I will start by adding 3 to both sides. That will leave me with 2t squared equals 2. I can then divide both sides by 2 and get t squared equals 1. And then I can square root both sides, remembering that if you square root both sides, you need to include a plus or minus. There are two things that I can square to get 1. I can square 1. I can also square -1. So when you introduce the square root, it's actually to fix a squaring issue, not a square root issue. When you square things, the positive and negative will give you the same result. And the square root of 1 is just 1. Please don't leave square root of 1 written there. Please rewrite it as plus or minus 1. So if t equals 1 or t equals -1, then h of t will also equal -1. Last part, h of t equals t. Sometimes when there's variables on that other side, people think that it should somehow be different, but it really shouldn't. It's the same idea as the last one. I'm supposed to take the original function, 2t squared minus 3, and set it equal to a t. I will approach the solve a little differently because now I have a t squared term and a t term, so I don't think square roots are going to help. So I'll set it equal to 0 by subtracting t from both sides. 2t squared minus t minus 3 equals 0. And then I will hope that I can factor. If I fail on factoring, I can always use a quadratic formula, but a lot of these will be factorable. So I think I need a 2t and a t to get the 2t squared. And then I get a 3 and a 1, and one of them is negative. So I'm thinking, this is what I'm thinking at first, because that gives me a 2t on the outside and a 3t on the inside. If I make it a positive 2t and a negative 3t, that will add up to that negative 1t in the middle. That's always the goal, is when you FOIL it back out, the outside plus inside gives you that middle term, that t term. So that's my factoring, which means that 2t minus 3 has to be 0, or t plus 1 has to be 0, which means that 2t equals 3. Since I'm running out of room, I'm going to go ahead and say divide by 2, which means t is 3/2, or t is -1. So we typically get 2 answers from a quadratic, from a nice quadratic. We can also get 1 answer or no answers, depending on what's going on, but we're kind of anticipating 2 solutions when we start on a quadratic. All right, so that's all the messy functions algebra. Keep working on it, keep embracing it, think carefully about those difference quotients. Thanks for watching.